Hi, welcome to my talk on unlocking privileged access management, HCP Boundary with Terraform. My name is Mattias Fjellström. I'm a cloud architect consultant working at Solidify. This is my second year as a HashiCorp ambassador, and I'm also a user group leader for the user group, HashiCorp user group in Gothenburg, or Göteborg, as we say in Sweden. So, Boundary. I expected you know a little bit about Boundary to be able to follow along my presentation, but this is at a high level what HashiCorp Boundary is. So this is a copy-paste from the documentation. Basically, Boundary is an identity-aware proxy aimed at simplifying and securing least privileged access to cloud infrastructure. So at a very high level, we have some sort of trusted identities, and through the use of Boundary, these identities will be able to access basically anything with a network address. So Boundary is sort of tech agnostic, so it doesn't care if your resources are running in AWS, in Azure or GCP or wherever it might be. But for a demo, we need to pick some sort of tech stack to work with. So I will be using the community edition of Terraform. I will be using the managed versions of Boundary and Vault in the HashiCorp Cloud Platform. I am using AWS for all of my cloud resources, and I'm using Microsoft Entra ID as my identity provider. And finally, I will be using GitHub to highlight sort of a use case for Boundary. All right, the infrastructure we will be looking at looks like this. So on the left, I have my HashiCorp Cloud Platform organization with Boundary and Vault. And on the right, I have my VPC running in AWS. I have two subnets, one public and one private. I have a Boundary worker in each of the subnets. And in the private subnet, I have two types of targets that we will access. So one is an EC2 instance, and the other is RDS Aurora cluster, basically. I have set up private peering between my virtual network in HashiCorp Cloud Platform and my VPC in AWS. And this allows for private communication with Vault. All right, so we will be looking at a lot of Terraform code. We'll briefly look at some Go SDK code, and finally a little bit with the Boundary CLI in GitHub. So mainly we will focus on how you configure Boundary using Terraform. There is a lot of code, so I won't be able to go through everything, but I will provide links for the GitHub repository for later. So specifically, we'll be looking at scopes, auth methods, users, groups, roles, etc. We'll spend some time looking at workers. Then we move on to host catalogs, host sets, hosts, and credential stores and credential libraries. And finally, we'll be looking at targets and aliases. We'll also see how you can use the Go SDK and the Boundary CLI for two different automation scenarios. So let's jump to Visual Studio Code to take a look at my Terraform configuration. So I split it up in two different directories. In the first directory, I have my HCP resources and some AWS networking resources. Let's just look at specifically what's important for Boundary on the HashiCorp Cloud Platform. And it's this resource. It's fairly simple to configure. I give it an ID. I provide an initial username and a password. I specify what service tier I want. I'm using the plus tier here just to be able to use all of the features that are available. I'm configuring a maintenance window for my cluster. So this is whenever updates of my cluster could happen. So that's basically it. Below here, I configure a virtual network and a Vault cluster as well, but we won't spend time looking at that. My second directory contains more of the actual Boundary resources. So first of all, if I scroll down and look at my providers, of course I have my Boundary provider, and I've configured it down here. I need to provide the address, and the auth method login name and password. Once that is done, I can start configuring resources. So one of the first things you will configure in Boundary is scopes. So in Boundary, you can configure resources into various scopes. So at the top of the hierarchy, you have the global scope. Inside of the global scope, you can create organizations. That's what I'm doing here. So I create an organization called HashiTalk Secure 2024 organization. And inside of my organization, I create a project called AWS Resources. I have a few other scopes down here as well, but these are mostly for illustrative purposes, just to illustrate how you can configure or organize different scopes. So you can take a look at that on your own time. Once we have a scope set up, it's natural to want to set up a method for your users to sign in. So you can use the password auth method that comes along with your HCP cluster, or you could use the configure your own OIDC provider. And that's what I've done here. I configured one for my Entra ID tenant. I'm placing it in a specific scope, so I'm configuring it for my project scope. And I'm specifying it's the primary for the scope. And then I have a number of OIDC specific configuration here. Most importantly, I have the client ID and the client secret, and these come from my Azure AD or Entra ID configuration. If you're interested what that looks like, I have a file down here called Entra ID, so you can take a look at how you can configure Entra ID for this. All right, so we have our scopes, we have our auth methods. The next thing we might want to do is start configuring a few roles. So a role in Boundary is exactly what you might think it is. So it configures the sort of permissions that users and groups have. And permissions are provided in these sort of grant strings. So we won't spend time learning about these. The documentation is excellent. I suggest you go read about grant strings. But I have a few roles set up. I have one reader role, which I assign to everybody. I have an EC2 role specifically for accessing my EC2 instance targets. Currently, I haven't assigned anybody to this role. Likewise, I have roles set up for accessing my Postgres database, but here as well, I haven't assigned any principal. So we will be doing this later with the Boundary CLI. I have a few more roles, but most importantly is that if you have some sort of automation account, for instance, you want to automate certain stuff in a Boundary using, for instance, GitHub or an AWS Lambda, then you most likely want to set up users and roles for those automation accounts. So that's what I've done here. I have a role for Lambda, I have a role for GitHub, so they are allowed to do certain sort of automation tasks. Let's jump into managed groups. So a group is just a collection of users. A managed group is a group that actually exists inside of your identity provider. So I have groups inside of Entra ID, and the managed group is basically the corresponding group in Boundary. So whenever a user from one of my Entra ID groups signs in, it will be assigned to one of these Boundary managed groups. So groups are, of course, a great way to assign permissions instead of assigning permissions directly to users. All right, so moving on, let's jump immediately to workers. So workers are sort of the second main piece of Boundary. We have the Boundary control plane, and you have Boundary workers. So I have two workers. I mentioned I have one in the public subnet and one in the private subnet. So let's just look at the public worker. First of all, I configure some networking permissions so it will be able to communicate with what it needs to communicate with, and other things that need to communicate with the worker is able to do so. So you can look through these security group rules, what is required. But most importantly here is I have set up a module for instantiating a worker. So what that looks like, let's open up the module. Basically, you create a Boundary worker resource, very easy to configure. But then you need to create the Boundary worker configuration, which is an HCL file. I'm using this template file function with this template. So you can look through this. This is basically HCL with some Go syntax language included. Next, I will be running the boundary worker as a service, so I configure a service configuration file. I will be writing this file to the instance using this cloud init configuration. I'm installing boundary and so on. So there are a lot of details here, but let's just scroll past everything. Finally, I create the AWS instance. So this is the actual worker. It's running on an EC2 instance in AWS. The private worker looks almost identical, so we won't have to go through it in detail. All right, let's move on. So once we have like all the basics set up and we have our worker set up, the next step is to start thinking about what we want to access. And this is where hosts come in. So let's focus on the EC2 host. So in this case, I'm creating a host catalog for my EC2 instances. A host catalog can be either static or dynamic. So in this case, it's a static catalog, which means I specifically add hosts that I define like statically. Dynamic host could be like where Boundary actually discovers hosts based on tags in AWS in this case. I create my actual host where I point to the private IP of my EC2 instance. And next I have a host set. So you can group similar hosts into a host set. In this case, I have a single host, but still I use a host set just to show you that this resource exists. So think of a sort of an auto-scaling group where all of the instances are identical. These are perfect to place in a host set. We have our hosts. We also need, or most likely will need, credentials to be able to access our resources. So this is where credential stores come in. And the most important resource to focus on here is the Vault credential store. So here I configure like how can Boundary communicate with my Vault instance. And once that is set up, I can configure credential libraries. So a credential store can contain one or more credential libraries. And a credential library is basically, it outputs credentials with the same access rights. So for a given credential library, all the credentials coming out from there will have the same sort of access rights. So in this case, I have SSH certificates coming out of this credential library. So the details here are fairly straightforward once you learn how it works. You can look through this on your own time. I also have credential stores for Postgres for producing read and write access to my Postgres database. All right, the final piece of the puzzle is the actual targets. So once you have credentials and you have hosts, you can combine these pieces into something called a target. So a target is basically what I said. It's the combination of one or more hosts, injected credentials, broker credentials, and a port to connect to. So this is what makes up a target. So in this case, I have a target for an EC2 instance. It will be pointing to my EC2 host set. It will use the SSH injected credentials that we looked at briefly. It will also use some broker credentials. We won't spend time looking at these, but it's good to know that you can have sort of simple JSON credentials that you just inject that the user might need for some reason. The difference between injected and broker credentials is basically that injected credentials are never visible to the user, while broker credentials will be visible to the user. Here I have a Boundary alias. So this is a new resource which came with Boundary 0.16. So this allows the user to just specify this simple value when it wants to connect to a target instead of having to like find out the ID of the target and then connect to that. So that's basically all the details we need to look at the moment. A lot of details, of course. You need to spend some time looking through this to really understand what's going on. Right, so let's just spend some time looking in the Boundary admin UI. So here I have signed in with my admin account. And this is the first screen I can see. I can list all of my organizations. So I have a few organizations. The most important one is the HashiCorp Secure 2024 organization. We can see that I have session recordings. So these are whenever somebody signs into an SSH type of session, it will be recorded. So we can take a look if we want to. Session recordings are stored in storage buckets. So you can see how this is configured in the code. I didn't show it, but you can take a look on your own. You can have storage policies, which basically configures how long should storage session recordings be stored. I have aliases. So this is where I can see the aliases I've set up and what target it points to. I can see my workers. So I have my private and my public worker, and I have two HCP managed workers. So this is kind of interesting to know that when you set up HCP Boundary, you get two workers, which you can use for accessing any publicly available targets that you might have. I can see my users. So I have my AWS Lambda admin account. This is an automation account. We didn't look at it, but it's there. I have my GitHub automation account. I have the admin user that I've set up together with HCP Boundary. And there are some users that also comes along. I can see groups. So I have a group set up for my automation users. I see that I have two members, my Lambda function and my GitHub account. I can see my roles. So here, for instance, I see my GitHub automation role. I can see what principals are assigned to it, and I can see what grants are included in this role. Under auth methods, I see the password auth method. So this comes along with your new Boundary cluster for free. And this is what allows you to sign in using the admin user to start with. If I go to organizations and I click on my organization, we see that I can click on auth methods. And here I see enter ID. So this was the enter ID OIDC type of method I set up. Likewise, I could have different roles in this stage. I can have other groups and I can have other users. And here I see I have two users set up. So these are users actually existing in my enter ID tenant. We see that I could have different storage policies for this organization, which basically means that, for instance, you might have one organization where you would like to keep the recordings for a long time, while in a different test organization, you might not want to store it more than a day, for instance. If I go to projects, I see that I have 3 projects in this organization, one called Azure Resources, one AWS Resources, and GCP Resources. I open up my AWS Resources, and inside of here, I can see if there are any active sessions. Currently, there are no sessions. I can see all the targets that are available here. I have three targets. I can see my host catalogs, my credential stores, groups, and roles. Let's go back to my organization. There was one thing I forgot to show you. If I go to my auth methods and I click into enter ID, I can see managed groups. So these are the managed groups which are reflected from my enter ID tenant. So I have one on-call group and one all users. So whenever a user belonging to, for instance, the on-call group signs in, it will be automatically associated with this corresponding managed group inside of Boundary. So let's jump now to how is this, what does it look like in practice? So this is the Boundary client running on my Mac. So let's just sign in with a user. I will begin by signing in with the admin user. So this is just to be able to show you everything, all the targets available. So the targets are loading here. We see I have 3 different targets. I can click connect on my EC2 instance and the connection will be set up. And if I go to the shell tab here, we see that I can connect to this specific target. So now I am inside of my EC2 instance. I didn't see any credentials. I didn't need to know anything exactly where the instance is running. I was just able to simply connect to it. So end session. So I will sign out and we'll look at a different example. So let me just make sure I am in the correct user. I choose a different scope to sign into. So in this case, I choose my organization scope. This is where I configure my Enter ID authentication. So if I click sign in, now you won't be able to see the sign in box, but I'm picking one of my user called lane buck window. And authentication was successful. So when the user is signed in here, we see that no targets are available. So in this case, this user has no specific permissions inside of Boundary. So I will illustrate how you can provide your users with access. So there are a number of ways of doing this, of course. In this case, I have set up sort of an issue ops approach. So now I am signed into my GitHub organization with my user lane buck window. I can go to issues inside of my repo and then click on a new issue. Now I configured an issue template called boundary access request. So click on get started. I say that I give it a title, EC2. I want to access this EC2 instance. I provide a reason because I want to access it for 3 hours. And submit new issue. All right, so an issue has been submitted. And if I go to my admin user, I can see the access request over here. I can open it up. All right, looks good. Let's go to actions. We see that an action has been triggered. And we see that lane buck window request your review to deploy the boundary. So I can review, I can approve and deploy. So this only an admin user would be able to do, or you can just allow it out of the box if it's nothing sensitive. Going back to a lane buck window, we see that the issue is still open. If I look at the actions, we see that it's running. So it goes through a number of steps. And there it's done. If I go back to my issue now, we see that the GitHub bot has been commenting here that access has been granted. All right, what does that mean? If I go to my Boundary instance or my Boundary client and I refresh, we see that now I have access to this EC2 instance. So I can click on connect. And I can click on the shell tab and we see that now lane buck window was able to access the machine as well. Okay, so that's one way of doing it. And to remove access, once the user, either the time has expired, I have an automatic cleanup to remove the access, or I can just close the issue. If I close the issue, we can see that another action is triggered. And this action will basically do the reverse work, so it will remove the access that was granted. All right, so that was basically how you can use the Boundary CLI. Of course, you didn't see that it was the CLI. Let's look at the workflow. So this was when I created an issue, this workflow was triggered. That's the trigger when a new issue is opened. And the most important step here is the configure access step. So we can take a look at here. We see that I'm using the Boundary CLI to make a number of requests. So I'm just fetching the correct user ID, I'm fetching the correct role to assign the user to, and then I'm adding a principal to this role. And once that is done, I'm posting a comment. So this is one way to use the Boundary CLI for automation. I also mentioned that you can use the Boundary SDK, the Go SDK. So I have another use case here. We won't have time to go through how it works. But basically, I have an alarm in AWS, and whenever that alarm is triggered, I will assign access to targets for my on-call group. So imagine that there is some issue with an EC2 instance, for instance, an alarm goes off, and then the on-call group is assigned access to be able to look at what's going wrong. So in this case, I'm using the Go Boundary API. So this is excellent support for working with boundaries. So you can do all sorts of automation scenarios. So whenever an alert is triggered, I'm calling this assign on-call role function, which basically just fetches the principal ID for the principal. In this case is a group in Boundary, and it's adding this principal to a given role. So you can do all sorts of things with this. So take a look at the source code in the GitHub repository to find out how this works in practice. All right, that was sort of a hurricane of information. So what did we actually learn here? Well, you will need to spend some time going through this code on your own, but what you will notice is that configuring Boundary with Terraform is fairly straightforward. Once you have all the basics set up, there will be some sort of general workflow for new targets, and this is like no matter where your targets are running, so if it's in AWS or Azure or whatever. First, you will configure the target resource, so this might be setting up a new EC2 instance, setting up a new database, setting up a Kubernetes cluster, for instance. Then you will configure the required boundary resources. So most likely you will need to add host catalogs, host sets, hosts, targets, roles, etc. And you most likely will need to add like configuring credential injection or brokering with Vault. So this will require some configuration in Vault as well. All right, so as I said, it was a whirlwind of information. But I suggest you go to this first QR code. It will be taken to the GitHub repository where you can see all of the details. And if you have any questions, feel free to reach out to me directly on LinkedIn. You can visit my blog. I write a lot about Terraform, Boundary, Vault, and other interesting topics. And if you're based in the Gothenburg area, feel free to join the HashiCorp user group. And this goes even if you're outside of the Gothenburg area. Feel free to reach out. Yeah, so that's it. Thank you for listening. Bye.